We're back. All right. So we are on the back of the review. Is everybody getting that? 2, 4, 6? No. Thanks. Find the equation of the tangent line to the curve at the given point. All right. Let's do it. Now, remember that the nice thing is I'm given the coordinate, right? 1, 0. I don't actually have to find the y value. Oh, sorry. 1, 0. 0, 3. Losing my mind. And the nice, wow, even that case, look. 0, 3. I gave you the y-intercept.
Wow.
That was generous. All right, so let's find the derivative because the derivative is the slope, right? Honestly, this is our answer. Something x plus 3. We just got to figure out what that something is. Like that's calculus in a nutshell, right? Figuring out the slope of the tangent line at any given moment. So cool. All right, so finding the derivative will tell us the slope. Remember, the derivative of ln of x is 1 over x, right? The derivative of natural log is 1 over that thing. Well, remember that this is like saying 1 over, so f prime of x is equal to 1 over 7x squared minus 2x plus 5. And you might be thinking, wait a sec, Mr. Laverick, you forgot to take the derivative. But remember that it's 1 over the original times the derivative, because it's a chain rule, right? Times 14x minus 2. Now, remember that there was that special rule where we could have just gone straight to saying the derivative of the inside, the derivative of this piece, divided by its original. 14x minus 2 over 7x squared minus 2x plus 5. Okay, there's our slope, right? Let's plug in, oh, sweet. Let's plug in x. What's x? So what's my slope? Negative 2/5, right? So m is going to be negative 2/5. So negative 2/5 x plus 3. Questions about that? Ooh, that was a lot easier. Shall we continue to number 11 or 12? Excuse me. Let's do it. Use logarithmic differentiation. Ooh, that's exciting. Okay, now logarithmic differentiation just basically says, well, let's take the logarithm of both sides, the natural logarithm, ln of y, ln of this whole chunk, 2x to the 4th plus 5 squared, x to the 5th minus 2 to the 3rd. And now we start breaking it down. ln of y is equal to ln of 2x to the 4th plus 5 squared. Multiplication on the inside becomes addition of the logs. ln of x to the 5th minus 2 cubed. Powers of a log become products in front. So this becomes ln of y is equal to 2 ln 2x to the 4th plus 5 plus 3 ln x to the 5th minus 2. And now I start taking my derivatives. Remember, on the left side, I am taking the derivative with respect to x. So this becomes 1 over y prime, right? So because the derivative of ln is 1 over that thing times the derivative of the inside. Well, what is the derivative of y? Y prime. And now on the right side, it's 2 times the derivative of this piece. Now remember, we just went over that rule about ln. You take the derivative of the inside divided by its original. 8x cubed over 2x to the 4th plus 5 plus 3 times 5x to the 4th over x to the 5th minus 2. Let's multiply those constants up to the numerator. So this becomes, again, 1 over y prime is equal to 16x to the third, 2x to the fourth plus 5, plus 15x to the fourth over x to the fifth minus 2. And now at this point, I am okay with you just multiplying the y over to the other side. So y prime, is essentially just y quantity, 16x to the third over 2x to the fourth plus 5, plus 15x to the fourth over x to the fifth minus 2. Now, if you'd like to, if you feel so inclined, you could put the y back in. I mean, you know what y equals. Y equals y equals 2x to the fourth plus 5 squared times x to the fifth minus 2 cubed. You could plug that in as y, but you don't need to do that. Questions on that one? All right, let's keep it rolling. Did anybody still need that? Okay. Find the derivative. 3 to the 5x squared plus 2x minus 3. Okay. Now, you got to remember the rule about b to the x. This is on the formula sheet, the one that you don't get. D over dx of b to the x is b to the x ln b, right? B to the x ln b. But you not only have to use that rule, you have to chain it with the derivative of the exponent, right? So this becomes f prime of x is, okay, b to the x ln b. Notice that the b value is 3 in this case. So it's 3 to the 5x squared plus 2x minus 3. The original x, right? The original exponent times ln of 3. That's just the derivative of with the 3, right? The base of 3. Now what we have to do is take the derivative of the exponent, because again, this is a chain rule. So this becomes times 10x plus 2. I'll put that in parentheses. And I can leave that like that, because it's all multiplication. I could reorder it if I wanted to. I could say ln of 3, 10x plus 2, then 3, 5x squared plus 2x minus 3. But I can leave it like that. That's fine too. What's up? We good? Marcy, you all right?
Yeah.
You sure?
Yeah.
You positive?
Uh-huh.
Okay. Any questions on that one? Okay, let's take a look at the next one. Oh, now this is where it starts to get fun, isn't it? This is section 3.9, related rates. Now, I have not looked at the key in a while, and nobody asked me questions beforehand on this one, so what's that? Hold on a second. Mr. Grove's giving out free t-shirts. Sorry. I should have the key just in case, because I just replies all. Darn it. Gosh, I hate when people do that. Man. Don't you hate when somebody replies all to a big chain email?
Yes.
I'm that guy.
Like text message.
I'm that guy.
You're that
I'm that guy. I just did.
Oh.
What a dinosaur. I was like, only old people do that. You know? Only old people do that. I am very.
I'll take a t-shirt.
Yeah, I know. Like literally, that was it. That was my email. I'll take a large. It's like, gosh, get your paint on, Grandpa.
The library cake club starting today in the pod. We got this pie wrecker in the tree.
It's just the math department, but still.
The whole math part will now give you a large shirt. Each one.
Okay. Okay, here we go. I just want to have this up just in case I don't want to steer you in the wrong direction. Confuse you more than you already are
I
confused.
don't know the sphere formulas.
No, that's okay. If you don't know a formula that's presented on a problem, I can give that to you if you don't know.
Okay.
Yeah.
That would be very.
Yeah, that's fine. No, I'm not going to make you, know those.
Yeah.
I haven't printed it out, but I think I do actually write them in there.
Okay.
Like what formulas you actually
That
use.
would be helpful.
Yeah, this one's 4/3 pi r cubed. And again, that is also, that's kind of an obscure one. I don't know. Surface area, volume of a sphere. I don't know.
Yeah, that one I just.
That's not one that's too well known. Now I won't give you ones like we've had to use Pythagorean theorem and stuff like that. So like that you should know, but like the volume and like surface area formulas, yeah. Okay, radius of a sphere is increasing at a rate of 4 millimeters per second. How fast is the volume increasing when the diameter is 80 millimeters? All right, so the volume formula, volume is equal to, again, 4/3 pi r cubed. We know that dr dt is 4, right? The rate at which the radius is increasing is 4 millimeters per second. What we are looking to find is dv dt. dv dt when d is equal to 80. Okay, if d is equal to 80, what's r? 40, right? Because we will use a 40 in our formula rather than the 80. Okay, let's see. Let's find the derivative. So this is dv dt is equal to 4/3 pi. Now pi stays in there because again it's just a number. And then we say 3r squared dr dt. Remember, that's like a chain rule. That is like a chain rule. I'm finding the derivative with respect to time on r. That's like implicit differentiation. So I take the derivative of the r. That's why you see the 3r squared. Excuse me, the derivative of r to the third. That's why you see the 3r squared. And then I multiply it by the derivative of r, which is dr dt. Now, this 3 and the 4/3, that just becomes 4. So dv dt is equal to 4 pi r squared dr dt. And I have everything I need to know. So dv dt is 4 pi times 40 squared times 4. Okay. 4 pi times 40 squared times 4. Whoa. 80,000? Yeah, I wrote 25,600 pi. 25,600 pi. Is that the same number? Yeah, cool. 80,424 0.8, we'll go 8. 0.8, and what's our label here? So we are talking about how fast the volume is increasing, and it's talking about it in millimeters per second. So a volume would be millimeters cubed per second. What's wrong, Marissa? You can say it out loud. I guarantee if you're thinking it, other people are thinking it too.
In like the second line, it's
right here.
Yeah. Did you just take the derivative of r?
Yeah. this part right here. Yeah, I took the derivative of r to the third to make it 3r squared. And then because I'm technically finding the derivative with respect to t, that's why I have to multiply on the derivative of r, which is dr dt.
Okay.
Yeah.
Okay.
Does that make sense?
Yeah.
Okay. And then from there, I know everything else. I just simplified down the equation and there we got it. Questions about that one? All right, let's do another one. A cylindrical tank with radius 7 meters. Again, like this one, I would give you this formula.
This is not a cone.
There's no what?
It's not a cone.
It's not a cone. Yeah, in that case, you just multiply by 1/3.
Yeah, but for this, it's being filled, and I don't like the cone one.
Oh, okay. Sorry. A cylindrical tank with radius 7 meters is being filled with water at a rate of 3 meters cubed per minute. How fast is the height of the water increasing? I mean, that's such a cool problem. Like, we can actually calculate this. Like, we're calculating the rate at which it's filling up. How cool is that? Like, we've got this cylindrical tank, and it's just like filling up with water, and we're calculating like how fast is that height actually decreasing. That's just so cool. All right, cylindrical tank. Volume is equal to pi r squared h. All right, we know dv dt. That is 3. We know r is 7. Now, let me ask you something. Is r changing in this problem? No. R is going to be constant. So you know what we can do with that 7? Let's plug it in right now. V is equal to pi times 7 squared h. I can plug it in before taking the derivative because it will not change. That may have thrown you off a little bit. These dang small flies are still flying around this building. I don't know. They've been here since the summer.
Yeah, they've been here all year. We're not having it.
V is equal to 49 pi h. Okay, that simplifies our life a little bit. Because now when I go to take the derivative, it's dv dt is equal to 49 pi. Why did I write an h? 49 pi dh dt. And I know dv dt, so it's 3. So it's 3 49 pi dh dt. Okay, I divide over the 49 pi. 3 divided by 49 pi is going to be dh dt. Let's see what that actually comes out to be. 3 divided by 49 pi. 0.019. Height is in terms of meters. And I believe it said meters per minute, not meters per second. Yeah, meters per minute. So every minute, it's going, the height is increasing at about 0.02 meters. About 20 centimeters per minute.
Would it have messed you up if you wouldn't have plugged in the 7, like if you would have just taken the derivative beforehand?
Well, you would have tried to take in the derivative of it. Let me see real quick. Because you would have said dv dt is equal to pi times 2r dr dt, dh dt. And, well, I don't know what that is. And then that means there would be some sort of dr dt, but there is no dr dt, right? Okay. You know, there is no change in your radius.
Yeah.
So that would be weird. All right, any other questions on that one? Find the linearization of the function at the given value. Remember, the linearization equation, L of x is equal to f of a plus f prime of a times x minus a. But remember that it's really just this slope of, it's just the equation of the tangent line. Like, if you forget that formula, you just have to remember that linearization means the equation of the tangent line at that point. That's really what that means. If you don't remember the formula, just find the equation of the tangent line. So this is f of a. So f of a, the y value. Now remember that in this case, like a is -2. That's what that notation is saying. But I need to find f of a. So f of -2 is, well, let's plug that in. We've got -2 to the third minus -2 squared plus 3. -9. So L of x is equal to -9 plus f prime of a. Okay, let's find f prime. F prime of x is 3x squared minus 2x. So f prime of -2 is 3 times -2 squared minus 2 times -2, which in this case, minus 2 times -2, 16. Okay, so f prime of a, which is 16, and then quantity x minus a. Remember, x stays in, and I'll just make that a plus 2. And now we just simplify down. So L of x is equal to -9 plus 16x plus 32. And then combine the -9 and the 32. 16x, it's -9 plus 32, 23. 16x plus 23. Again, if you had forgotten what the linearization equation is, because that's kind of a weird one, remember that it's just the slope, it's just the equation of the tangent line. So what you could have done is said, okay, -2 comma what? Well, -2 comma -9, right? You could have found this coordinate to be, come on, blue, please. You could have found this coordinate to be -2 comma -9. And then said, okay, let's find the derivative. Okay, check, done. 3x squared minus 2x. Plug in -2. Okay, we did that, 16. And then done, y plus 9 is equal to m x plus 2, which is essentially the same thing, right? And then distribute the 16, get the 32, subtract away the 9, you get our 23. Okay. Remember, the linearization just basically means the tangent line equation. Number 17. Only 3 more to do. All right. So find the differential dy and then evaluate dy for the given values. Okay. Now remember that the differential equation is basically saying dy is equal to f prime x dx. That's our differential equation. The differential on y is equal to the derivative times the differential on x. Okay, well, the differential on y is what we're going to evaluate, right? That's what we're finding. So let's find f prime x. Okay, quotient rule. So f prime of x is going to be derivative of the top times the original bottom minus the derivative of the bottom times the original top, all divided by the bottom squared. Simplify down, which is 2x plus 12 minus, distribute in the negative, 2x minus 3 over x plus 6 squared, which gets us down to a 9 over x plus 6 squared. So dy, oops, not over dx, that's a habit, is equal to 9 over x plus 6 squared dx. When I say to find the differential dy, that is what I'm talking about. Honestly, I'm really just asking to find the derivative, but to write it in the differential equation. Because now I say, okay, find if x is negative 3, and I only want the differential on x to be 0.25, what's my differential on y? And understand what I'm asking here. I'm saying find how much y is going to vary. If I tell you where I'm going to, negative 3, and I say, okay, I'm going to let x vary 1/4, a quarter, right? I'm going to let x be close enough to be a quarter. How much does that change my y? How much does that affect my y? Okay, so dy is going to be 9 over negative 3 plus 6 squared times 0.25. All right, so, that's easy. 9 over 3 squared, which is 9. 9 over 9 is 1. So this actually ends up being 0.25. So what is that telling me? That's telling me that if I let my x vary 1/4, my y will also vary 1/4. Okay, that's kind of cool. Now, does that happen everywhere along this thing? No, not at all. If I chose a different x value, well, then my window on my x might make my y vary a little bit more than just 0.25. Okay, 2 more to do. Ooh, prove the identity. All right, now, this is where, again, you get your section 311 formula sheet. This one, that I also need to make more copies of. I'm going to provide you a clean copy of this. You don't have to have your own. I'll have one of these for you. But unfortunately for this one, do I see any, excuse me, do I see any identities with just cosine and sine? Unfortunately not. So that must mean I need to use the definition. What does the definition mean? I need to use the e to the x minus e to the negative x. Like, for example, I know hyperbolic cosine is e to the x plus e to the negative x over 2. And I know that hyperbolic sine is e to the x minus e to the negative x over 2. Let's see if I can manipulate that into just being e to the negative x. That's the goal. Okay, well, I've got common denominators, which is convenient. So this is all over 2, e to the x plus e to the negative x. And now let's distribute. This is minus e to the x plus e to the negative x. Well, that is convenient, isn't it? Because now this gives me, okay, I've got e to the negative x plus e to the negative x. Well, if I've got 2 of them, hey, look, there's a blimp. You can see it on Mrs. Nampul's window. I mean, it's kind of weird to see something in the sky. Other than a plane. Hey, look, something shiny. So if I've got e to the negative x and e to the negative x, that is 2 e to the negative x, which is just e to the negative x.
I don't want tomorrow's just
QED.
Yeah. Now, know this again, like this is on the second half of the review, right?
Yeah.
So it's probably on the second day.
Yeah.
Probably.
It's a good thing.
So if your time is limited in terms of studying time, study the first half. Okay, find the derivative. All right, let me go back to my formula sheet. Oh, this is an easy one. I don't even need my formula sheet. I actually have to do the chain rule, don't I? Yeah. So what is the derivative of sine? Cosh, right? So f prime of x is cosh x squared times 2x. Oh, that's easy. I should have put something harder on that on there. All right. So that's your chapter 3 test. I think you see that it covers all the sections, bottom to top, section 1 to 11. In my opinion, the stuff that's kind of foreign to us is the stuff in the middle of the chapter. Like we've done a lot of finding derivatives. That's the beginning of chapter 3. This stuff right at the end, the hyperbolic stuff, that is pretty close to our memories because we just did it. The stuff that's going to be a little weird is the related rates, the implicit differentiation, the logarithmic differentiation, that middle of the chapter stuff, section 3.6, or excuse me, whatever that was, in the middle of our chapter. That's going to be the stuff that you may forget. So go back and look back at your homeworks, look back and make sure that you really understand what's going on. See how the problems relate from the homework to the review, and see which ones you need to kind of refresh your memories of. That's my suggestion to you. Yeah. If you have any questions, I usually get here about 7:05 in the morning. If you have any questions, come in tomorrow. Yeah. We good? Okay. Let me turn off the video.
This is terrible.